a couple things I'm going to leave out as far as activity series, which I know you know nothing about at this point. So I'll point that out for you when we get there. So that's one topic. The next topic is stoichiometry. Okay, and that's a big topic. So I'm going to try to simplify as much as we can. And then from there, we're going to talk about limiting reagents. And Ms. Gordon loves this type of problem. So just a heads up, it's going to be on your test. Okay, she loves it. So that will be enough for tonight. Okay. So you have a worksheet, like with a couple pages, like equations. You had stoichiometry on it that Ms. Gordon gave you on Monday, right? Okay, like 4 pages or something. Okay, and you started that first page, right? With the empirical formula and molecular formula. Okay. So the next 3 pages, we've got like equations, and then we've got stoichiometry. So I'm going to use some of this, but I'm also going to put in some extra stuff too. So that should help. So have that out, but also have most of the paper out, because there may not be enough room to write everything down on that. Okay? So that's where we're going to start. As far as chemical reactions go, for your class, there are several different types of chemical reactions. So we've got synthesis reactions. Okay? And that in your chapter is in chapter 3 of your book. Okay, so synthesis reactions and decomposition reactions are both in chapter 3. These 2 types of reactions you do not have to know how to predict the products for in this class. Okay, so that's something you want to write down. So no predicting products for these. They're just kind of hard to predict the product for, which is why. Okay, so a synthesis reaction, what you're looking at here is a generic formula. You have an element A plus an element B, and then you're basically going to combine those 2 to form a compound. Okay? So you're taking 2 things and then just putting them together pretty much. Okay? So that's a synthesis reaction. Best example, or one example, nitrogen's diatomic. Everybody knows that, right?
Mm-hmm.
Okay. So nitrogen plus hydrogen, so 2 diatomic elements. When you put those 2 elements together, you form a compound called ammonia. Okay? So A plus B gives me AB, basically. That's a synthesis reaction. Does that make sense? Okay. So that's the first type of reaction. Now, this can be pretty much any element. So usually you're going to have gases that combine pretty easily together. Okay, that's what you're going to see most often. You could have a metal and then a non-metal. That's another one that you might see. Okay, so it really just depends on the type of reaction. So, balancing reactions. When you're looking at a particular type of reaction, we have this little space in front of each of our elements or our compounds. So this little space here is going to represent a coefficient. And that coefficient is basically going to balance our equation for us. So as we're going through, we'll go ahead and balance them. So first of all, on each side, this is your reactant side of the equation. And then yields. And then this is your product side of the equation. So on each side, on this side I have nitrogen. So I want to take that element, and then on this side I have hydrogen. And I want to figure out how many do I have on each side. And I want to balance those out with my coefficients. So here I have 2 nitrogen, is that 2 subscript. And then I have 2 hydrogen, that's my subscript. But on my product side, I have 1 nitrogen, right? Okay. And then my hydrogens, I have 3. So they're not balanced right now. Okay, balance just means I have the same number of nitrogens on both sides of my equation as I do same number of hydrogens. Okay? So what I want to figure out is what do I need to put in these blanks to make sure that my number of nitrogens is the same on both sides and my number of hydrogen is the same on both sides. Okay? So easiest thing to do here, does anybody know? Okay, if I put a 2 in this blank, it's kind of like guess and check. If I put a 2 here, then that changes my number of nitrogens here. 2 times 1 is 2. Okay, so you can just assume that's a 1. So this number is multiplied by whatever that subscript is, okay, for that compound. So that's a 2, and then 2 times 3, so that would give me 6 here. Okay, so now my nitrogen's balanced. Everybody agree? That's great. But my hydrogen's off. So I have 6 here, I have 2 here. Easy thing I can do is put a 3 here. When I do that, 3 times 2 gives me 6. And so, change that to a 6, I'm done. It's balanced. Does that make sense? Okay. So, that's how you balance an equation. So these numbers in front are your coefficients. And if you don't have anything, you can put a 1 or you can leave it blank. It's up to you. Okay? So very, very important numbers for our stoichiometry that's coming up. Okay? Any questions there on that one? So that's just an example of a synthesis reaction that you might see. Easiest way to tell that you have a synthesis reaction is having a compound on your product side, the AB here. Okay, because it'll always be written that direction. So your reactants are always on this side, your products are always on this side. Okay? That's important because the next type of reaction is the opposite. It's a decomposition. So we have a compound starting out, AB, and that compound is going to break down. So the simplest breakdown would just be into those 2 elements again. Okay? That's not always the case. Sometimes it's a mixture. And that's where this gets really hard to predict the products. But that's the simplest form. So it's kind of the reverse of that synthesis. Okay? So on your reactant side, you're always going to have a compound, and then on your product side, you're always going to have the breakdown products of it. Okay? So those are the first 2 types. An example that you might see of decomposition. So we've got lead 2 carbonate, and this breaks down. Hey, come on in. Okay, to these 2 products here, which may not be blatantly obvious. So we've got a compound here, and this compound is going to break down into our lead 2 oxide, and then carbon dioxide as well. Okay, so a typical carbonate ion, one of the reactions that you'll learn about is that it likes to break down to carbon dioxide, okay, frequently. But again, this is not one that you have to predict the product for. You just have to be able to identify it. Okay? So you've got a compound on this side, and then you've got breakdown product plus breakdown product. So you'd say decomposition reaction. And then you would also be expected to balance this reaction. Okay? So, is this reaction balanced? Can you tell? So, in front of each of these, our coefficient here, do we have the same number of lead on both sides?
Mm-hmm.
Yes.
Yes. Okay, so I have 1 here, okay, and then I have 1 here. Okay, what about carbon? Do you have the same number of carbons on both sides? Yeah,
Yes.
I have a carbon here, and I have a carbon here. Okay, what about oxygen?
Yes.
In this case, yes. It doesn't always work out that nicely. So I've got 3 here, and I've got 1 plus 2, which is 3 on my product side. So it is balanced. Okay? So if you'd like to put the 1s in front of it, that's fine. Okay? Does that make sense? Those are the easy ones. Is that okay there? Okay. So that's the first 2. Those 2 are in chapter 3 of your book. Okay? So your book divides